Hello, fourth grade, and welcome to lesson 4 of module 3. This module, we're talking about structures and functions of living things. And for this lesson, we're going to talk about the role of animals' eyes. Let's go ahead and watch our short video, and then we're going to jump in.
Do you know what this is? Yes, it's an X-ray. In fact, it's an X-ray of an iguana. I want to be a veterinarian when I grow up. Then I will use technology like this to care for sick and injured animals. I want to work in a zoo. That way I can help all kinds of animals, even my favorite animal, penguins.
All right, now for our first page in your science for this lesson, on the role of animals' eyes, you're going to open up and read the scenario between the two friends, decide which one you agree with the most, and explain why. So remember to use complete sentences and neat handwriting, or if you're going to be typing it up, if you're working from home, you can do that as well. Just make sure to check your spelling and grammar as best as you can. Once you've completed that, we're going to go on to the next page, and we're going to take a look at the photo of animals' eyes, and we're going to write down what questions you guys have. So let's go ahead and take a look at that picture together. So this is our photo of different kinds of eyes. You can pause the video if you like so that you're able to stop and take a good look at it and write down any questions that you have. Once you've completed writing down your questions, you're going to read about the STEM career connection. We're going to read about a veterinarian. A veterinarian is an animal doctor. And then you're going to go on to the next page and answer your two questions. How is a veterinarian similar to a doctor that you might go to? And what might happen to the horse if its medical condition is not treated? So all of the answers to both of those questions can be found right here in these two paragraphs. Once you've completed those, you have an inquiry activity that you're able to do at home. And you're going to go over this inquiry activity called In the Blink of an Eye. What makes animals like humans blink? In this activity, you will conduct an investigation to explain why you think we blink. You will change several conditions and see how they affect the rate of blinking. So what does that mean? We're going to figure out what makes animals or people blink. And you're going to change a couple things and do a couple things that will make the person blink more often and see if that actually happens. How does changing the amount of light or wind in an environment affect the rate of blinking? So do you think it's going to make you blink more often or less often if it's windy or if there's a really bright light? Go ahead and write your prediction over here. You're going to tell me, I predict, and then tell me what it is. And then you're going to say because, and you're going to give me your reasoning for it. Once you've completed writing your prediction, you're going to carry out the investigation. So please be very careful. Again, if you're working near anybody or you have a fan or anything near someone's face, you do have to be very gentle. You're going to work with a partner. This can be anybody at home. And you're going to have your partner begin reading from the science handbook or other reading material. So the person's going to be reading. And what you're going to be doing is you're going to either put a really bright light near them, or you're going to put a fan near them. So once your partner's reading, start the stopwatch. So you're going to be timing for 1 minute how many times your partner is blinking. So this is the first time you're going to do it without anything. So no extra light, no wind, just to see how many times they blink regularly without anything. So you're going to do for yourself, where you're timing your partner, and then they're going to time you. So you're both going to have measurements here. Now for steps 3 and 4, you're going to repeat what happened, but you're going to have them sitting near a really bright light. So they're going to be reading and you're going to be measuring how many times they blink when there's a really bright light near them. And then they'll measure it for you. And then for the last one, you're going to repeat those same steps, but you're going to have someone sitting, or you and your partner are going to take turns sitting in front of a fan and see if the extra wind from the fan causes you to blink more often within that minute. So you're going to be timing for a minute for each one of these. The first time you're timing it is with nothing, just to see how many times you normally blink. The second time is counting how many times you blink with a bright light near you. And the third time is how many times you blink when there's a fan near you or, blowing wind towards your face. Now, please don't set the fan on high, just on low or medium is fine, just for you to be able to do the experiment. And then of course, you're going to be switching and doing the same thing for your partner. After you've completed this, look at the data that you collected. So the data is the information that you put up here in your table. Take a look at all the information that you gathered. What pattern or patterns do you see? How are you seeing things change? Are you seeing the amount of times you blinked get higher or lower? The amount of times your partner blinked get higher or lower? And when was that happening? And then under where it says communicate information, why do you think there was a change in the rate of blinking? So why do you think there was a difference? What inference can you make about why other animals blink? So what inference? An inference is an idea based on things that you learned. So what idea do you have about why other animals blink? And do you think that all animals blink? And then go ahead and explain why you think that in your answer below. Once we've completed those pages, we're going to go on and we're going to take a look at our vocabulary for this lesson. So our vocabulary words are the words image, concave lens, translucent, reflection, convex lens, opaque, refraction, and transparent. So let's go ahead and take a look at the vocabulary words, and all of these are found in Google Classroom as well for your convenience. Now, the first word we have is the word image. An image is a mental picture of an object based on the light rays bouncing off of the object's surface. So for you to be able to see an image, there has to be light, correct? So an image is what your brain understands. It's a picture that you make in your head based on the light that's bouncing off of that thing. Reflection is the bouncing of light waves off of the surface. So think about when you look in a mirror, right? You can see your reflection. Now, reflection, we can also reflect light. So if you shine light at a mirror, you can see that the light will bounce off the mirror and onto another surface. Refraction is the bending of light as it passes from one transparent material to another. So we're going to see a lot of examples of these. So these will make a lot more sense in a bit. Then we have a concave lens. A concave lens is thinner in the middle, and it always makes objects look smaller. A convex lens is thicker in the middle and it makes objects look bigger. So think of a magnifying glass has a convex lens. Now, next we have the word transparent. Transparent things are see-through. It means it lets all of the light pass through the object onto the other side so you can see it clearly. So transparent means clear. You can see all the way through it. Translucent only lets some light through so that objects on the other side appear blurry. So translucent doesn't let all of the light go through. You can't see through it clearly. And then opaque means it completely blocks the light from passing through. So these are three different levels. So transparent is all the way see-through, translucent is a little bit see-through, and opaque means it's not see-through at all. So think of like a wall. You can't see through a wall. Something that's transparent is like a window. And something that's translucent is, if you think of some of those windows that have kind of a clear film over them where you can kind of see through it. It'll let some light through, but you can't see through it clearly. All right, let's go ahead and jump into our next part. And we're going to read a handout that's also attached in Google Classroom that's called The Way Eyes See It, on how eyes work to allow animals to see. And then we're going to answer the questions after we finish reading. So the first question we have says, using information from the science file, draw and label a human eye below. So that's something you're going to pay attention to, and it's something that you're going to see in the handout. So you're able to copy it over and just make sure you label it correctly. The way eyes see it. How do eyes work? Eyes are like cameras because they take pictures of the world around. They send these pictures to the brain. The brain uses the information from the eyes to understand the world. The eyes you see. When you look at your eyes in a mirror, you can see these parts. You can see the eye socket. So your eyeball sits in an empty space in your skull called an eye socket. So the space where your eyeball goes is called the eye socket. Your eyelids. Eyelids blink to keep your eyeballs clean, moist, and protected. Pupils. The pupil gets bigger and smaller to let in light you need in order to see. So the pupil is the little black part in the middle. So when it's dark outside, your pupil opens up wider to let in as much light as possible so that you're able to see. And when it's really bright, it gets small and really tight because too much light can actually hurt your eyes. Then we have the iris and cornea. The iris is the colored part of your eye, and the cornea covers the iris. The cornea lets light enter. So the iris is the colored part that you see, and the cornea is kind of like this clear overlay that goes on top of it. The sclera is the white part of your eye, and you guys can see that all the time. The eye inside. Your eyes have many parts that you cannot see. The retina has cells called rods and cones. Rods help you to see black, white, and gray, and the cones help you to see colors, and those are all located on the inside. The nerve path. So all of these are nerves that connect your eyeball to your brain. The rods and cones on the retina change all the shapes and colors you see into nerve messages. The nerve messages travel along the nerve path to the brain. Your brain reads these messages, and then you can tell what you're seeing. So this collects all of the information from your eye and then sends it to your brain. And then the lens right here is right behind your pupil. A clear lens is behind each iris. The lens collects light and then moves it back to the retina. About animal eyes. Animal eyes are different from human eyes. Different animals have different types of eyes according to where and how they live. All animals' eyes use light in different ways to survive in the wild. Some animals have eyes on the front of their head, while some have eyes on the sides of their head. Still, other animals have eyes on top of their head. Some animals can see many colors. Other animals can see only black, white, and gray. Some animals have good eyesight. Others cannot see very well. So this is a chameleon. And here we have a picture of a hippopotamus, and you can see how their eyes are different. Scope it out. The eyes of predators. Animals that hunt other animals are usually on the front of their head. This helps them to see how far away something is. It also helps them when the hunted animal is trying to get away. The eyes of prey. Prey are animals that predators eat. Their eyes are usually on the sides of their head, and this helps them to see danger coming from the sides and from behind. So here we have an orangutan. We have raccoons, a toucan, a cat, and a crocodile. So take a look at how their eyes look different from one another. Eye shine, eye shade. You might have noticed that the eyes of some animals seem to shine at night. Deer, cats, crocodiles, and other animals have reflectors in the back of their eyes. These reflectors help double the amount of light their eyes can use at night. These night lights help animals hunt prey. They can find food in the dark too. Scope it out. The eyes of a crab are at the end of stalks. The stalks stick up when the crab is buried in the sand. The eyes of the snail are at the end of its tentacles and can bend around to see things up close. Lions have reflectors in their eyes. They're good night hunters. Seabirds need to find food near water. They have a special red oil in their eyes that works like sunglasses. It filters out blue light rays from the sea and sky. The oil reduces eye glare, which helps birds find food. All different kinds of eyes. A cat's eye view. A cat's eyes are similar to human eyes in some ways. A cat's eyes and our own eyes are both located on the front of our head. Our eyes are also in the front of our heads. A cat's eyes are different from our eyes in some ways, though. Cats have excellent night vision, which helps them hunt food in the dark. In dim light, a cat's eyes muscles open the pupil into a wide black spot. This lets in as much light as possible. Do cats need glasses? Cats can see well at night. They can also detect sudden movements with their eyes. Cats have eyes that help them see their prey and hunt it down. Objects that are nearby, though, can look fuzzy or out of focus. Eyes underwater. Most fish have eyes on the sides of their head. Fish eyes also have special rods that allow them to see movement underwater. These features help fish see creatures that may want to eat them. They also help fish catch prey moving past them. The scallop has 100 eyes around its shell. These eyes help the scallop see shadows of predators that come at it from all directions. So you can see all the little eyes all the way around. Eyes in the sky. An owl's eyes are 100 times more sensitive to light than human eyes. This helps owls see prey at night. The eyes of an eagle are similar in size to human eyes. Objects appear much larger to eagles than they appear to humans. That's why eagles can see prey from a distance. So when they're flying really high up above the ground, because they see things bigger than we do, they're able to see things that they want to catch and eat more clearly from farther away. Bug eyes. Flies, bees, and other insects have compound eyes that look like two big bubbles. Each eye can have thousands of small lenses. These lenses allow insects to detect danger coming from all directions. This is why it's so hard to swat a fly. The eyes of moths absorb a lot of light. Some moths have special coatings or coverings on their eyes. This coating keeps their eyes from shining at night. This hides them better from predators. Eyes are amazing. There's so much to see. Now let's go ahead and head back over here. So draw and label a human eye. Now, if you're going to use the diagram here, you can go ahead and either use the front-facing diagram or you can use this one that shows the inside. Either one of those answers will be fine. Just make sure you draw carefully and label it. Number 2, explain how light enters the eye, is focused on the retina, and is interpreted by the brain. So all of that information you're going to find in this section about how light enters the eyes. So you're going to find that information in these first 2 or 3 pages. For number 3, what is the meaning of the word pupil on page 2? What is another meaning for the word pupil? What clues in the text show you which meaning is used on page 2? So here on page 2, we have the word pupil. Actually, it's on the first page. So go ahead and look up the other meaning of the word pupil if you have a dictionary on hand. If you do not have a dictionary on hand, I'll let you in and let you know that another meaning for the word pupil is student. So a student is also called a pupil. So here they're asking you, what is the meaning of pupil on page 2 when they're talking about it in terms of science? And what other meanings for the word pupil? What other meaning for the word pupil is there? And then what clues in the text show you which meaning that they're using in our science handout? Next, we're going to watch a short video called How Do Animals See? So go ahead and take a look at the question first before we get there. That way you know what you're looking for. Our question is asking, how do dogs see differently than humans? So let's go ahead and jump back over here and watch our video.
Our eyes allow us to see some pretty spectacular things. Vibrant colors, cool shapes, beautiful scenes. There is so much to see in the world around us, but have you ever thought about how animals see the world? Let us start by talking about man's best friend. Dogs might have serious skills when it comes to playing fetch, but their vision skills are not nearly as strong as their human owners. Take a look at this picture. This is how a human eye sees this scene. And this is how dogs would see the same scene. The biggest difference is that dogs cannot see reds and greens, but they can see yellows and blues. How about cats? How does their vision measure up to ours? Cats also have trouble seeing colors. Most of the colors they see are muted and dull, but they have very strong night vision. Cats have an extra layer of tissue in their eyes and have larger pupils than humans, helping them to see much better in dim light. One creature actually has 2 sets of eyes. Snakes in the pit viper family can literally see the world in 2 ways. They use their eyes to create a visual image of the world like humans, but they also have heat vision. They have 2 tiny pit organs on each side of their head that act as infrared sensors, allowing them to sense when their prey is near. They can actually see body heat. It is fun to see our world in a different way.
All right, now that we've completed watching the video, go back and think about how dogs' vision is different than ours. So I'm going to play this section on dogs for you one more time in case you forgot. And we'll go ahead and review that information so that you're able to fill it in for your question.
Man's best friend. Dogs might have serious skills when it comes to playing fetch, but their vision skills are not nearly as strong as their human owners. Take a look at this picture. This is how a human eye sees this scene. And this is how dogs would see the same scene. The biggest difference is that dogs cannot see reds and greens, but they can see yellows and blues. How about cats? How does their vision measure up to ours?
All right, so let's go ahead and head back to our pages. Now that we've finished watching the video, how do dogs see differently than humans? So you can go ahead and put in the information from the video there. And then we're going to skip down to our next page, and we're going to read in our textbooks on page 340 and 341 about the bouncing and bending of light. So reflection and refraction. Your questions for this section are going to be, what is the difference between reflection and refraction? How do reflection and refraction allow animals to see? And then explain the difference in how a concave lens and a convex lens affect an object's appearance. So how do they affect the way that you see an object if you're looking at it through a concave lens compared to when you're looking at it through a convex lens? All right, so let's go ahead and pull up our science handbook. The bouncing and bending of light. Reflection is the bouncing of a wave off of a surface. Objects that reflect off of a flat surface obey the laws of reflection. The angle of an incoming light ray equals the angle of the reflected ray. Flat mirrors. When you look at a flat mirror, the image you see appears to be behind the mirror. Of course, you're not really behind the mirror. It seems like light rays are coming out of the mirror, but in fact, you are seeing rays that reflect off of the mirror. Concave mirrors. A mirror that is curved inwards is a concave mirror. Light rays that strike this type of mirror bounce inward. The light image you see depends on how close you stand to the mirror. If you stand very close, your image will appear larger than you are. If you stand farther away, your image will be upside down and smaller than you are. Convex mirrors. A mirror that is curved outwards is a convex mirror. Images in this type of mirror always appear smaller, and they always appear to be behind the mirror. Reflected images may appear behind the mirror, and these are the faded bulbs that you're seeing over here, or in front of the mirror, which are the bright bulbs that you're seeing. A convex mirror allows the driver to see a wide area behind the car. So these little mirrors that you'll see sometimes attached to a side mirror on a car are convex mirrors. Refraction of light. Refraction is the bending of waves as it changes angles passing from one substance into another. Light slows down when it comes from one material into a denser material. This decreases the speed and causes the light angle to change, or its direction to bend. Light speeds up when it moves into a less dense material. This increases the speed and causes the light to bend in the other direction. Flat lenses. A clear piece of glass or plastic through which light travels is called a lens. Light slows down when it enters a lens, and then it speeds up when it exits the lens. If the lens is flat, the light path shifts a little, but its final direction doesn't change. For a concave lens, a lens that is thinner in the middle is a concave lens. Light that passes through a concave lens spreads outwards. Objects always look smaller when you look at them through a concave lens. Convex lens. A lens that is thicker in the middle is a convex lens. The images that you see when you look at an object through a convex lens depends on how far away the object is. Up close, the lens will cause the object to look bigger. Far away, the image will appear upside down and will be smaller. So let's take a look at these quickly. So a flat lens, the direction kind of stays the same. You'll see it kind of bend a tiny bit, but it still ends up going ultimately in the same direction as it started to pass through. A concave lens, so think of a cave. You see how it's curved inwards like that. So the curve goes in, just like in a cave, you would walk into it. This is a concave lens, it bends inwards. And this is going to cause, because it's thinner in the middle, the light is going to spread out, or the rays that pass through it are going to spread out on their way out of this lens. So things are going to look smaller when you're looking at them through a concave lens. A convex lens, think of a magnifying glass. When you hold it close to an object, that object looks bigger than it really is. And convex lenses are wider in the middle, and you can see it kind of looks like the letter V at the bottom to remind you, convex. Now for your questions, the first one asks, what is the difference between refraction and reflection? So over here, you can see the beginning of both of these pages. Reflection is the bouncing of a wave off of a surface. So it's when a wave bounces off of a surface. And refraction is when it bends and changes direction when it passes through a surface. So refraction is when it's changing its direction a little bit, it's changing its angle when it passes through something, and reflection is when it bounces off of something. How do reflection and refraction allow animals to see? So reflection allows you to see because the light waves are bouncing off of something, so you're able to form an image because your eyes need light to be able to send a message to your brain. So light needs to be bouncing off of that surface in order for you to be able to see it. Refraction also allows you to see because it adjusts how big or small you're seeing it. So depending on the lens that you're looking through, either a flat lens, a concave lens, or a convex lens, it changes the way that you're seeing the object in front of you. So it says over here, if we look at our caption, concave lenses are used in eyeglasses for people who are nearsighted or have trouble seeing objects that are far away. Different lenses are needed for people who are farsighted or have trouble seeing objects that are close. So your concave lenses over here are used for people who wear eyeglasses and can't see things far away very clearly. So if you're sitting in the classroom and you have a hard time seeing the board, but it's easy for you to see the paper in front of you, you're going to get glasses that have a concave lens. And then explain the difference in how a concave lens and a convex lens affect an object's appearance. So all of that information is going to be right here in these two little paragraphs. It tells you the difference between them. All right, now moving on, we're going to read our next two pages, page 342 and 343, and we're going to answer these questions. So we have questions 8 and 9 over here. What does it mean if an object is transparent? Give an example of when having a transparent material is helpful. And number 9, How would you know if a material is opaque? When would you find an opaque material useful? And then you don't have to worry about the I can statement. So let's go ahead and jump back into our science handbook. And we're going to flip to our next page and read about the bouncing and bending of light. You see images when light reflects off an object and enters your eye. The diagram shows the different parts of the eye that light passes through. Both the cornea and the lens refract the light so that it bends towards the retina on the back of the eye. The retina sends signals to the brain and that you interpret as images. So when light and things are coming through, it's going to come in and it's going to go through the cornea and the lens. So here's your cornea, it's that clear overlay on top of your iris, and then the lens over here, and it's going to refract them or bend that light and send that image to the back of your eyeball where your retina is. And that's going to send the messages to your brain so you know what you're looking at. Transparent, translucent, and opaque. Light that strikes a material may pass through it. Materials that allow most light to pass through are called transparent. Clear glass and plastic are transparent. You can clearly see objects when you look at them through a transparent material. So remember, transparent means clear or see-through. Materials that blur light as it passes through are called translucent. So wax paper and frosted glass are examples of translucent materials. If an object allows little or no light to go through it, it's called opaque. So opaque means you can't see through it. Factors that affect light transmission. Whether an object is transparent, translucent, or opaque depends on the type of material, its thickness, and the color of the light. The thicker objects have more particles to absorb photons. Remember, photons are little bundles of light. So they're more likely to be opaque. Some objects will be opaque, transparent, or translucent for only one color of light. Shadows. Opaque and translucent objects block light. The area behind these objects is darker. The darker area is a shadow. Shadows are the absence of light. When an object is between a light source and another object, it casts a shadow on the other object. So think about when you're standing outside in the sun and you can see your shadow. That's because the light is hitting your body. Your body is opaque. Light can't pass through your body. So when you look and you see your shadow, that's the area where light is being blocked from passing through. Early in the morning, when the sun is low in the sky, you cast a long shadow. Sunlight travels towards you at a small angle. At this angle, there's a long distance before the sunlight hits the ground behind you. As midday approaches, however, the sun rises in the sky and the angle of the sunlight increases. Throughout the morning, your shadow becomes shorter and shorter. Shadows depend on the angle and the distance between the light source and the object. They also depend on the distance between the object and the place where the shadow is cast. The closer a light source is to an object, the larger the shadow an object will cast. So over here, they have an example of opaque materials, these cardboard boxes. You can't see through them. And on the right side, we can see that this person has their shadow cast right behind them because the sun is coming down in this direction. It's hitting their body, and their body, because it's opaque, is blocking the light in that section. And that's how you can see their shadow. Okay, so what does it mean if an object is transparent? Give an example of what having a transparent material, when having a transparent material is helpful. So why would it be helpful to have something that's see-through or clear? So give the definition of transparent, an example of when it's useful. Give an example or give the definition of the word opaque and when having something opaque would be useful. And then, like I said, you don't need to do the I can statement. Once you've completed those pages, we're going to go ahead and jump into our next set of pages and explore our digital interactive about why do some people need eyeglasses? And we're going to figure out the reasons why people need corrective lenses for clearer vision. And then we're going to answer the questions after we're done. So over here, you just have these 3 questions. We're going to describe how you would see objects if you were nearsighted. What kind of lens would you need to correct your vision if you were nearsighted, and how do you know? And what kind of lens would you need to correct your vision if you were farsighted, and how do you know? So let's go ahead and take a look at that video, or sorry, that digital interactive.
Nearsightedness. Nearsightedness means you can see better up close than you can at far distances. Eye shape. Nearsightedness occurs because the eye is longer than average. Image. The mountain image appears blurry in this eye because it is larger than average and the mountain is far away.
Okay, so we can see that the issue here is that when someone is nearsighted, the eye is longer than it's supposed to be. So when the image is going back to the retina, it's larger than it should be. So it's not clear and they're not able to see it.
Lens. A lens can correct nearsightedness. Image. The lens moves the location of the image in the eye so that it appears clearer.
Now take a look at this lens. What shape is this lens? The one that we said that curves inwards. We said that this one is called a concave lens. So think about a cave, right? You would walk into a cave. It's open and it goes deep on the inside. So this is a concave lens, is used to correct nearsightedness. Now let's take a look at farsightedness.
Farsightedness. Farsightedness means you can see better far away than you can up close. Eye shape. Farsightedness occurs because the eye is shorter than average. Image. The eye chart image appears blurry in this eye because it is shorter than average and the eye chart is close to the eye.
So here you can see the shape of the eye is a little bit more squished. It's not as long as it should be, or not as rounded as it should be. So these images are really blurry when they're trying to see something that's close to them.
Lens. A lens can correct farsightedness. Image. The lens moves the location of the image in the eye so that it appears clearer.
Now here you can see they're using a different kind of lens. And this lens we said is thicker in the middle. And this is called a convex lens. So remember, this looks like a V at the bottom, convex. And it moves the location of where the image shows up on the back of the eye in the retina so that it's easier for you to see it more clearly. So how would you just see objects if you were nearsighted? You can go back to the beginning of this activity and we can see that nearsightedness means we can see objects that are near very, very clearly. So if it's close by, we can see it clearly, but if it's farther away, it appears blurry to us. What kind of lens would you need to correct your vision if you're nearsighted, and how do you know? So you can take a look over here. We have a concave lens, and you can go back to the reading for more details on why concave lenses are needed for nearsightedness. And for number 3, what kind of lens would you need to correct your vision if you were farsighted, and how do you know? So again, over here for farsightedness, we said we would need a convex lens that's thicker in the middle. And you can go back to the reading again for this section to find additional details about how you know that you would need that particular kind of lens. Once you've completed that, we're going to wrap up our lesson, and we have a performance task at the end. As a veterinarian, you will make a model to show an animal eye how an animal eye works to refract light. So remember, refract means to bend light. You will investigate what happens when you change the distance between the lens and retina in an eye model. How is the quality of an image affected as you change the distance between the retina and the lens? Write a hypothesis in the form of an if-then statement. So if I do this, then this is going to happen. You're going to need a magnifying glass, a table lamp, so any kind of light source doesn't have a shade, and some kind of screen or just blank wall to project on. Experiment using the hand lens and the lamp to refract light, forming a crisp image of the lamp on the projection screen. Draw and label the diagram of your setup. So you're going to draw how you're setting this experiment up. Then you're going to start answering your questions. What did you have to do to get a crisp image of the lamp on the screen? So when they say crisp image, they mean a really clear image, one that's not fuzzy. Number 2, what did you notice about the image you focused on the screen? And why did the image appear that way? And number 3, how's your setup a model of how the eye works in animals? Number 4 asks, do the results of your investigation support your hypothesis? So did what you think happened actually end up happening? Yes, if it did, and explain why, or no, if it didn't, and explain why you think it didn't. And then you're going to answer your essential question. Think about the photo of the animal eyes that you saw at the beginning of this lesson. Use what you've learned in this lesson to explain how animal eyes in the photograph are able to see. And I can take you back quickly to show you that picture. And that was this image right here. So you can go back and review this picture in order to answer that question. And then you don't need to complete the I did statement. That will take you to the end of this lesson, 4th grade. If you have any questions, let me know. Otherwise, I hope you have an amazing day. Take care. Bye-bye.